So in this first problem, we're given that f of x equals 3x cubed plus 1, and we're asked to find f inverse of x. One way of doing this is first we set y in place of the f of x equals 3x cubed plus 1. Now, some cases you'll hear switch the variables. I don't teach that method, so what I'll do is just solve for x. So we do all the steps we need to solve for x. So we subtract 1 from each side. Just cancel here. And we get y minus 1 equals 3x cubed. Now remember, we're undoing this. So we reverse our order of operations. So the next thing we have to do is actually divide by 3. So this cancels the 3's, and we get x cubed equals y minus 1. And the last thing we'll do is we'll take a cube root of each side, and we get x equals the cube root of y minus 1. And there's our inverse. Now, this problem did ask us to find f inverse of x, so what we'll do in our final step, we'll rewrite it, and this is telling us to use x as our input variable, so the cube root of x minus 1. In the second problem, we're given that g of x equals 3 raised to the x plus 1, and they want g inverse of x. Same start. We're going to let y equal 3 to the x plus 1. And again, we'll solve for x. So subtract 1 off of both sides. Get y minus 1 equals 3 to the x. Last step in solving for x, we're going to need to use a log or a natural log. I'll go ahead and use natural log in this case. So I have natural log of y minus 1 equals, now we can rewrite this, x times natural log of 3. I'm allowed to pull that exponent out front by properties of logs. Last step to solve for x is divide both sides by ln of 3. And we get x equals ln of y minus 1 over ln of 3. Or again, they had asked for g inverse of x, which equals ln of x minus 1 over ln of 3. Now remember, with properties of logs, we could have used log of x minus 1 over log of 3, or we could use the log base 3 of x minus 1. We will talk more about logarithms and exponential functions in a later section.